All right, questions. Feel free to just refer to any slides, anything I said. So this is your time, right? Anything you want to ask, except asking me what's in the test, except for that. Eh? Yes?
Do we have the thing you had earlier, the sample exam questions?
Sample exam, oh, you want me to go to that?
No, do we have that file, the PDF?
The PDF file? You mean the sample question I gave to you?
No,
or
the one you just had up there.
Oh, you want to look at that?
Do we have that? We do? Okay.
We do. You're talking about, okay, you're talking about the one over there. I would say you can still ask me questions. However, you don't need to worry too much about this particular exam questions. So it's created by instructor from other section. They have their own style. I have my style. So I would say if you are comfortable with the written question I gave to you, the exceptions, the aliasing, then that can give you some idea. However, in the actual test, I don't tend to give usually in the test any multiple choice. So it's more about explanation, justification, right? But my principle is I only test you what I teach, right? You shouldn't find any surprise if you study my notes. Okay. I remember. Let me just start something very quickly, very brief. One of you actually put on the Google Doc about this sample expression 15. Okay. I wouldn't go over that. That would take some time. But for that one, I want to point to you the thing you should pay attention to figure out the answer. Number one, if you look at the temperature class over here, okay, temperature, okay, over here. And then if you look at the constructor over here, you can look at the constructor here, which takes no parameter. And notice one thing. Every time you're trying to create temperature objects, by default, it's going to set it to be C, Celsius, right? That's one thing to note, one hint. And number two, so this is tricky, okay? I want you to pay attention to the table over here. This is not something I'll test you about, don't worry. I want to explain to you, okay? I briefly mentioned this in the class previously, okay? I want you to look at row number, okay, how about we'll compare. Row number 2 and row number 6. I want you to look at these two rows. You can see in row number 2, the units is simply a string literal, just F, okay? And in row number 6, it simply is a new string. Remember, it's anonymous objects. This is covered in the lab test, right? How you can create an object without a name. New string F. Row number 2 and row number 6, that's the trick. Okay? 2 and 6, to make the story brief. Okay? So let me switch the iPad quickly. So in row number 2, you have something simply string literal. On the other hand, you have row number 6, you have new string. And then that one there, you pass a string literal. So this is anonymous objects. Anonymous objects. Okay? So these two are quite different. Okay? How are they different? I'll point you specifically to the test question. If you go to this particular method over here, okay, look at the method set units over here. You can see that we're basically saying if the units you are passing is either C or F. In that case, that means the unit is valid, so we can simply assign. However, pay attention to what operator we're using. We're saying equal over here. And that's something we'll cover in the class today, just about equals method. Well, so are we comparing, tell me, are we comparing addresses over here, or we are comparing contents of the string? Very good, because that's equal. So that's the trick, okay? So now, whenever, you can just, it's more like a subtlety for Java and for many other programming languages. Whenever you see you're simply trying to compare a string together with, using addresses, using the equal operator to compare address with another string literal, it will be okay. Okay? So now I want to tell you this. So over here for F, so there is only a single object. A single object created for this literal. What I mean is, imagine this. Let's say if this is your project, okay? let's say your projects, you may have my class.java, and then let's say my class 1, and also you have my class 2. Let's say we got 2 classes. Doesn't matter how many you have, okay? So now, let's say over here, somewhere in your program in my class 1, you mention the string literal f. And somewhere in your my class 2, you also mention string literal f, okay? Here's the trick. As far as the compiler is concerned, they know that you're talking about the same string literal f, uppercase, twice or multiple times in general. What they will do is at the runtime, they only create a single object for this string literal f. There's only a single one. That's what I meant by single, okay? So that's why at the runtime, these two, there will only be just a single objects. In that case, if you simply want to use the equal to compare, it would just be aliasing. So that one, it would just pass. So that is why when you go back to the original test question over there, let me just refer you back to the table over here. Sorry, I'm missing it. Should be here. Okay? If you look at the table here, basically, row number 1 and 2, they're simply using a string literal. That's okay. You're just using the address operator to compare. So 1 and 2 will just pass. Okay? On the other hand, line number 5 will be okay because remember we set the default units to be Celsius. So that is just okay by coincidence. On the other hand, for row number 6, you're creating a new string object f. In that case, let's go back to iPad over here. In that case, this is every time a new object is created. So now let's go back there. So what's the catch over here? If you go back to that particular set units method over here. So now when we use the address operator over here to compare, so now the units is basically the new string f that we talk about. Is this the same object as the string literal? No, they're separate. So that's why this will just be evaluating the false. Okay. As I said, I wouldn't really test you about the difference between string literal and also new string. At least in my test, you don't have to worry. But for your curiosity, I want to point out to you quickly. Okay. So but if you want to explore more, feel free to drop by my office hour. I can explain further to you. But I don't want to waste too much time on this. Okay. Now back to your questions about slides or any. Well, if you simply want me to re-explain some concept, that's fine too. Just tell me. Of course, anonymous objects. Anonymous object is quite an easy idea. Okay, so let me just use some sketch over here. Okay, anonymous objects. I never know how to spell this. Okay, the way to think of it is basically objects for which you do not store their addresses in variables. That's how you can think of it. But now let me explain what I meant. Let's talk about what are the objects that are not anonymous. Okay, let's see this. Can we assume that we have a point class? Okay, we got x and y. Let's assume. Okay, that's the class we have seen many times in the class. Let's say we say points, and then P1 is assigned to new, and then we say points. And then we simply give the x and y, let's say 3 and 4. Okay, in this case, you can think about this is some objects in the memory, right? And now in this particular case, this is the name of variable storing that object's address. Let's go a little bit further. Okay, so now you can think about now this object here, we have a name called P1. So whenever you want to modify this particular object, you can use P1. Okay, let me go a little bit further. Aliasing. Okay, so anyone? So up to this point, can you give me a very concise definition for aliasing? Yeah, basically the same object, its address has been stored in multiple places, multiple variables, right? Pretty much you're getting close. Okay, so let's talk about aliasing quickly, and then I'll go to anonymous objects. So now over here, let's say we declare another point variable here. We simply say p2. But now I'm saying that p2 is now, rather than storing a new point object's address, rather than doing that, I'll simply copy whatever that's in p1 in there. Okay? So now at this point, we basically have two names for the same objects, right? You can think about now what we have is p1 is pointing to some objects, and p2, because of this particular assignment here, is also going to point to the same objects. Okay, and this object here is point. And by the way, for tomorrow's test, please make sure you're comfortable with drawing some object to trace programs on the paper. Okay, because you will not be allowed to use Eclipse. That's not the purpose for this written test. Okay, so now you got x and y over here. We got 3 and 4, 3 and 4. So now you can think about P1 and P2. They are the names for this particular objects. So now what aliasing means is, now if I want to modify this particular objects, it doesn't really matter which name I'm using. For example, if I simply say over here, if I say P1 dot, let's say set x. Let's say I want to set x to be 6. Okay? Basically, if you try to trace the code, you're saying, okay, now the dot over here, again, the dot here simply means look up the address. Look up the address that is stored in P1 and go to that particular location. Now, if you follow the path of P1, P1 actually points you to this particular object over here. So now you want to modify the object. So now you will change that to 6, right? It would be as if you actually said P2.setX. They will be effectively the same because they point to the same objects. You have two names for the same objects. Okay? So now we talk about when an object has a name or multiple names. That's the more common practice. However, as you get a little bit more experienced, you might find that sometimes it would be more convenient not to give a name for the objects because you simply don't need it. You only need the names of the objects if you want to call methods on that. But what if you don't want to call any methods on that? You don't just want to return. In that case, anonymous object could be useful. For example, let's say in the class called points, okay. Let's say we want to have some interesting method over here. Okay. Let's say we want to have the return type is simply going to be points. Okay, return type can also be a class. And then I want to say new points. Okay, it's just the name of the method. So it's going to be an accessor. And then I'm going to say over here, in order to create a new point objects, I need to pass all the necessary information for me to create it. In this case, x and y. Right? So I would say integer x and integer y. So here I'm omitting the constructor and x and y declaration, right? I assume it's quite obvious. So now let me show you the version without using the anonymous object, and then we'll see how we can simplify it. Okay. So now I can say, for example, because I know that eventually I just want to return a point objects, right? That's what you can see from the return type, right? So you want to eventually return the address of some point object. That's the goal. Okay, let's see how we can do it. What you can do is, first of all, I can say MP for new points. You simply assign to, I can simply create a new object over here, new points. And then I can pass x and y, right? Whatever x and y you give to me, x and y. And then I know that eventually I should return the address for these new points, right? I can say return MP. Okay, any question up to now? Is okay? So now you can realize that the only reason we are creating MP is because we want to return the address that is stored there. But we never try to call any methods on MP. That's something to notice. That could be a very motivating scenario for using anonymous objects. And notice that no method call. No method calls on the name you just used. So in that case, how can we simplify it? The way to simplify it will be, we can simplify this into simply say return. Now, rather than return MP, why don't we just return new over here? Basically, exactly the right-hand side over here. Return new, and then points, X and Y. So that's anonymous objects, right? So we are saying just return the address of this newly created objects on the fly. However, if you want to call any methods on this particular object here, you cannot do it within this method because it has no name. Okay? It depends on what you need. So let me give you a quick principle to summarize. So when should you use anonymous objects? When to use anonymous objects? Okay? The answer is, in principle, when you only want to pass its address without calling any methods on that. Okay, that's a principle. Make sense to you? Okay, no problem. Any question about anonymous objects? Okay. Okay, next one. Remember somebody talked about exceptions? Yes, what about exception? You want to say in general or specific parts? In general, okay. Okay, unless you have some specific slide you want to refer to, otherwise I'll sketch on the iPad, so that'd be easier. I think it's more important for you to get a big idea. Okay, for exceptions. First of all, why do we need exceptions? Exception, first of all, is for error handling. Okay. Error handling. Specifically, we want to force. So force here is the keyword, right? Remember, I tried to show you the two different versions, one in the console tester versus using exceptions. I wouldn't bother you with the console tester version. I assume you study for that, okay? We want to force the caller to somehow handle errors when they occurred. Okay, so now this particular, when we say force, there is the requirements, right, we talk about. It's called the catch or specify requirements, right? Okay, hopefully that sounds also familiar to you. Catch or specify requirements. Okay, first of all, that's why you're using exception. Whenever you're programming your software, you believe, at this point, I want to make sure anybody who's calling this particular method I'm implementing, if there's an error, I want to force them to somehow handle that. Okay, but let's see a simple example. Okay, let me just build some example from scratch. Okay, okay, let's try. Let's say the first one. Let's say let's just use a simple one. Let's use a different one. Let's say class. Let's say account. Let's say we got bank account. Okay, and then integer simply balance. Just make it simple. It should be double to be more realistic, but make it simple, just integer. So what I would do is, let's say over here, let's just have the default constructor, okay? And then let's say void, we have a mutator, withdraw. And then over here, integer, the amounts, A. Okay? Let's just make it simple. Over here, I'm the implementer for this account class. My intention is anybody who's trying to call the withdraw method, I want to make sure if they ever try to pass a negative amount to withdraw, I want to force them to handle that error. Okay, that's the intention. So like, of course, you can also say the amount cannot be too big. Let's make it simple. Okay, I can say if the amount is less than 0, and by the way, if I actually want to say another possible source of error, I want to say either when the amount is negative, or if the amount is somehow larger than the balance, right? Either way, I want to throw some exception. Now, you have to know for the lab test tomorrow how to use logical operators, right? Okay, so something I want to mention briefly. I'll just write it down. Or you can say, or A larger than the balance. Either way. In that case, we're going to actually give it an error. So now, in the console tester version, you will simply say system.out.print line and then print the error. But that's not the way to go, right? If you want to know the rationale, you can review the lecture notes. The way to do an exception, if you do an Eclipse, okay, you will simply say throw. And now this has to be throw rather than throws. Throw here simply means at this point I know that if the flow of execution at the runtime ever reaches this part over here, I know that the amount is either too small or too large. In that case, I'm going to signal an error to the caller for this method. Okay, I'll say throw, let's say negative amount exception. Okay, you can simply type it out first in your Eclipse, right? And then you'll simply give some error message over here. So you would say error negative amount, for example. Okay. Something like that. Okay, so that's a throw. As soon as we do that, first of all, you will see that there will be a red underline, NAE, because NAE doesn't exist. Yes? Oh, I'll get there, don't worry. Yeah, I just want to follow some flow. Yes? NAE is already a keyword? Throw new. Oh, you guys are good. Very good. I'm proud of you. Very proud. Hmm? We'll see you tomorrow. You know, either way, if you do very poorly, I'm still proud of you. Either way. Always proud of you. Thank you. Okay, so now I'm throwing a new exception over here. Good. So now, okay, the first thing you will see is, number one, you will see that red underline over here saying it doesn't exist. So there are two ways you can do it. But for this part, you don't have to memorize. I wouldn't test you on that. Every time I want to give you exception class, I'll give it to you. Okay, you don't need to memorize. You can either use Eclipse to generate this exception class. Okay, that's one way to go. You can also refer to the lecture recording. I also show you how you can do it. Very straightforward. Number two, you can simply type it out. Okay, I'll mention very briefly. So what you will do is you're going to create another class over here called negative amount exception. Okay, and then it's going to say extends, and you don't have to worry about extends at this point. After the reading week, we're going to talk about inheritance from scratch. That's the point we're going to talk about extends. For now, you don't have to worry. Okay, you say negative value, negative amount exception extends exception, right? And then something here. Okay, that's as much as I want to say just about exception. Okay, up to now. After this will correctly handle number two. So that means this class is now in place. So that should not be the source of error. But still, we're going to have some red underline in a different place. That's exactly what you just mentioned. Okay? What's happening now, you can think about it, is this. You can think about this method here has the potential. When I say potential, I mean it doesn't necessarily have to happen. It depends on the input value. If the input value is such that this condition here is satisfied, then we signal the error by exceptions. Has the potential of throwing an exception. However, we only throw the exception without handling it in this place. So now, as I said, you got two options over here. Either you can use the try, or you can use the specify, or catch with specify, right? As I said in the class, typically, it wouldn't make so much sense if you try do the catch option. I'll show you quickly, right? I didn't really show you in the class, right? So now you can have either catch or specify. If you try the catch option, okay? If you try the catch option, I'll sketch very quickly for you. What you would do is, you would say void withdraw, and with the parameter over here, and then you'll simply say try. You know what? Let me use a bit thinner, so otherwise I don't have enough space. What you will do is, you're going to say try over here, and then you will say catch. And in this case, we can catch the non-negative amount exception, right? And then you have something over here afterwards. And now imagine that over here, this block over here should appear just here. So you would say if something happened, and then we're going to throw new negative amount exception. Okay, so this is the case where you have to go with the catch option. Simply means you can see it is this place that we are trying to throw this particular exception. In the same place, we're saying we are trying to throw this exception. If it is thrown, go to the catch block. So basically, this is not very useful because the intention of throwing this exception over here is the caller calling this method should be aware of that. But now, if you choose this particular catch option here, it's already handled in the callee. It's not going to be a signal an error to the caller. So that's why this option here usually is not taken, even though it's syntactically correct. Okay? Let me just make a note over here. But I'm just saying, usually you will just opt for the specify option as opposed to the catch option in the very first place where you try to throw the exception. Okay? So now, not taken. So this is usually not taken by the callee. So callee, I say account and then withdraw. That's a callee. Throwing the exception. Okay, so now that's why you will see another option, right, in the very first place. So now what we can do instead is to say now, this is so-called the header of the method. You have the return type, you have the name of the method, you got the parameters. So now, between the parentheses and the curly brackets, we're going to insert to say throws negative amount exception. Okay, that we'll just simply declare. So that means anyone who's going to call this particular withdraw method, they will see as part of the API for this method here, it might throw this exception. So they got to try and catch that, or they can throw as well. Okay. Let me just say one more thing, and then I'll take question. Okay. I will continue with this small example over here. Basically, you can think about this is the very original source of the error, the very original source of the negative amount exception. Okay, just keep in mind. Now I'm just going to go a little bit further, just switch the slide. Okay, we're going to reuse this account class, right? And keep in mind, we already say throws here. So what I will do is I want to create another class. Let's call that account. How about call it clients? How about that? Okay, let's say we have class clients. And then let's say each client has a single account. Just make it simple rather than an array. Okay? And then I will simply say accounts over here, ACC. Okay? And then let's say if the client wants to withdraw, they can withdraw. Let me just call it pay. Let's say void, and then let's say pay. And they should pay some amounts over here. Let's say integer amount to pay. Okay, any suggestion about how to implement this? That should be a one-line implementation. Right? That's something you want to get used to. For the written test, maybe you can think more, but for the programming test, you got to be precise. Okay? Basically, think about what's happening here. In this client class, we are basically declaring an attribute of type of another class called account, right? So now, how can we pay? Okay, let me give you a little bit of description over here. So this pay here, I will simply give you some documentation. Okay, I would say charge the accounts of this clients by amount A. Okay, That should help you. Idea? By the way, should we return anything?
No.
We shouldn't. Good. That's good. Should we, let me see. I'm pretty sure you know the answer. Let me see if any other. Guys, try. It's okay to be wrong, right? If that's a test question, there should be only a one-line implementation, right? How can I charge the accounts of this particular clients? Yeah, exactly. Okay. So how do you deal with this kind of problem usually? First of all, since I know it's about the accounts for this particular client's class, right? So you look at ACC, and the type is simply just account. So now, in order to see what methods you can call this account, okay, I'll give you some principle here. In order to see what methods we can call on ACC, go to the declare type. Because in this case, we declare ACC to be of type account. So let's go to the account class quickly. If you go to the account class and we said it's only a single method withdraw, and that's relevant, right? So that is why you can say ACC, and remember that's the context object, right? We keep saying context objects, ACC dot withdraw. And then A. Okay, any question about the implementation?
So what about creating the instance of account?
Oh, how do we initialize the account?
Yeah.
So that's something I didn't really include. Of course, in order to initialize this ACC attributes, you typically initialize all the attributes in the constructor. For example, I'll just make it complete. So what you can do is, let's say, okay, I'll put it here. Okay, you can say account, the name of the constructor, and then, so now you have some option. What kind of parameter do you want to give? Okay, let's say, for example, maybe you can say string, the name of the owner, for example, right? And over here, you can simply say ACC, referring to this particular one, or you can say this.acc, right? We also talk about this keyword in the review. Or you should also know this very well. This.acc is simply assigned to new accounts. I have a very quick question for you in just a moment. And then new accounts, and then we can pass the name. Of course, we're assuming that in the account class, I also have a constructor over here. Okay, let me make it complete. In the account class, sorry. Oh, beg your pardon. Shouldn't this be clients? Yeah. Okay. I just realized that. Okay, sorry about that. That's clients. And now we're assuming that in the account class, we also got accounts over here. And then it will simply be string owner of this particular account. And now I can simply say, let's say string and other attributes. String name. Question for you. What should be the implementation to put over here? Would it be correct if I simply say name is assigned to name?
No, because it points to the...
Aha. Yeah, exactly. And there's one term we talk about, right? First of all, we know that first we have a clash. We have name over here. We also have attribute name over here. We have a clash, right? The name over here, which one does it refer to? Does it refer to 1 or 2? 2, agree? Okay, so if that refers to 2, this is a term that we call shadowing. Very good, thank you. Okay, shadowing. Okay, good. So now the way to get around with that is to say, rather than name, we're going to say this dot name. Okay, that's good. So now let me have a quick question for you, because you asked me about anonymous objects, right? So now in this case, after this line, okay, let me just point to the iPad. After this line over here, do you think the object over here is anonymous or it has a name? The new account over here, is it anonymous or it has a name? Well, easy. Basically, think about how you're using it. If you're simply using the new expression in the context of an assignment, the left-hand side must be the name. So now, in this case, what should be the name?
Context object.
Yeah, the context object, the this.acc, right? Okay. Good, everything is good. So now, let's now go a little bit further. Now let's go back to the story. If we have this particular block of code over here, okay, we simply say acc.withdraw, and also we know that from the constructor of the client class is also going to initialize the account appropriately. Okay, everything is working well so far. However, is this line going to compile? Okay, I'll give you a little bit hints. Since this line here is calling the withdraw, right? So that means withdraw is a callee, right? If I go to the withdraw here, is there something in the withdraw that will stop this line here from compiling?
Throws an AE.
Throws NAE?
Because we haven't come specified.
Okay, very good. So now if you go back to this particular, I'll go a little bit slowly here, because if you look at this particular method here, we say withdraw has the potential of throwing this particular exception, throws, right? That means any caller of this method should either catch or specify, right? That's the requirements, okay? However, we are not doing any of that, are we? We are not. So now, if we simply have that, they will simply say unhandled exception. Specifically, we are talking about NAE, okay? Negative amount exception, okay? So they'll give you a red underline, specifically this part here. Okay, so now we have two choices, right? I said only in the very original place where the exception is thrown. You typically only choose the specify option. That's the only place. So now in this place we have two options. Okay, let's go over the two options very quickly. Okay, we can either do specify, or we can do catch. Okay, let's do it very quickly, right? If you do the specify option, you basically say void pay, okay, whatever amount it is. I'm just using dot 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 to save. So now I have to say throws over here negative amount exception, right? Only put the name of the exception. And then after that, you can continue with the method call. So now you'll be okay. Okay, let me just be precise. Integer A. Okay, that's the specify option over here. Any questions about this? Specify option in some way makes your life as a callee easier. Sorry, okay, let me say it again. The specify option here is convenient for the current caller. The current caller is simply the account class, and then we are calling it within the pay. It's very convenient because I can simply say now this method here is simply just going to throw negative amount exception. So whoever is calling this pay later has to handle this exception, right? Because it throws. Okay, it just get propagated. Okay. What about a catch? Okay, let me just say one more thing. Okay, I will make a notes. So this means any caller of the clients. So we talk about the client class. Of clients dot, I'm just using dot, it's not a normal dot. I'm just trying to tell you what the caller is. Dot pay, any caller of this particular method must handle the NAE that's thrown. Okay? So now what about the other option, catch? How do we specify the catch option? So now this is more responsible, right? Because now I know that I'm calling this method here, and the method might throw this exception. I'm try that and catch it. Okay? So the way to write it would be, let me use pink, okay? So now what you would do is you will say void pay integer amounts. So now you don't see that throws as part of the header of the method. You don't see that. What you would do instead is going to say try, and then catch. Negative amount exception, right? Okay, I'll just say E here. And then in the catch, you can do something, okay? So now over here, are we just going to say ACC, right? Exactly this line, the same. ACC dot withdraw. Okay, let's go a little bit further, a little bit further. So this simply means the potential negative amount exception has been handled by this particular try and catch block. So now, any other caller who's calling this particular pay method, do they have to handle this exception anymore? The idea is they don't have to, because the exception is not propagated in this case, okay? So now, on the other hand, any caller of this particular method here, so we talk about the client class and also the pay method. The pay does not have to handle. Have to handle. Okay. Yeah. Any caller of this particular method, they don't have to handle anymore. Okay. That's a consequence of doing either one, and you should know them very clearly. Right. I would suggest, if this helped a little bit, but you don't quite get it yet, maybe you want to just review the part of the lecture where we talk about, remember the A, B, and tester, right? We got 3 classes. Slightly more complicated, but I think that can also give you a little bit more strengthening, okay, about this concept over here, okay? But the principle is the same. Either catch or specify.
It's pretty much a design decision.
Yes, correct. So in general, yeah, let's go a little bit further about design decision, okay? In general, let's be a little bit higher level. Let's say this. If I simply got my tester dot main, in general, this method calls, let's say, M1 from C1, and this M1 does C1 dot M1 calls C2 dot M2, and let's say also calls C3 dot M3, and this can just goes on and on and on for realistic application. You basically got a call chain, right? Okay. Let's say if it turns out this method over here throws, for example, negative amount exception, let's say. So this is the very original place where the negative amount exception is thrown, okay? We know that for this original place, we'll simply do the specify option. That's the very first place. That's the common practice. So now, you can think about different options. I'll use different color to tell you, okay? So now for C2.M2, who is the caller of C3.M3. So now we have 2 options, right? Either you can say specify. If you simply say specify, that means C2.M2 throws negative amount exception. In that case, should C1.M1 handle that? No, you have to. You have to. Let's say this. Now say the red one. So that means for M2, I simply say throws negative amount exception, right? That's exactly what I meant over here, and do something over here. So now, if this is what I do at this level here, so now for C1.M1, do we still have to handle this negative amount exception?
Oh, we have to specify our catch.
Yeah, that's true, but let's say for C2.M2, we simply use the specify option. So if you use specify option at this level, so now, what if you go to the caller of C2.M2? So now in C1.M1, the caller, should we handle that? We should, right? Okay, let's do it. In that case, I can, so now again for C1.M1, we also got 2 options. Either you want to do catch or specify. Let's say we do specify again, let's say. Specify, that means for the method, I'll say M1 over here, we also say throws over here, negative amount exception, right? In that case, okay, so that's how we handle that at this level. Now, question. If I go to the caller of C1.M1, which is tester.main, should we handle the NAE? Should we? Yeah, exactly. Think about this. Every time you have throws, that means the caller of this particular method must handle that. Easy principle. Okay, so now let's say for test domain, and this is the place where we typically do not try to specify any further. That's the last point before user of your program sees the result. So for over here, we'll simply do, let's say inside your main method over here, you'll simply say try, and then catch. Okay, that's typically. Let's consider a very quick alternative. There are many other alternatives as well. I'll just mention one more. Okay, so the one we just specified, you can really see is red. Okay, but if you bother to watch the recording tonight, you will see what I just wrote was just simply in red. That's one alternative. I'll give you another alternative. Okay, let me just switch. So let's say again we got tester.main. And then we got C1.m1, and also we got C2.m2, and then, okay, C3.m3, and so on. Again, the assumption is this particular method throws negative amount exception. Okay? So let's say this. We know that for this particular caller over here, okay, we have to handle it. Okay, let's say we still choose specify. Just choose one more thing. Okay, one more time. Let's say we choose the specify option. That means for M2, we simply declare to say throws negative amount exception. Okay, over here. Okay, so now we know that very well. If I go to the caller for this particular method, we still have to handle that, right? Because it throws. Let's say now, is a design decision. So I cannot really say in general at which point you want to do try and catch, at which point you want to do throws. It's completely up to your choice as a developer. Okay? So now, let's say our design decision this time is going to say rather than specify, we want to catch. Okay? So now let's do that. So that means we want to choose a catch option. So now under class C1, we'll say void M1. Rather than saying throws, we're going to say try and catch. So try, the method call, and then catch, right? I'm just omitting the syntax, so you know what to do. So now here comes the critical question. In a previous alternative, in C1.m1 over here, remember C1.m1 we chose specify. That is why in the tester domain, the caller, we still have to handle, right? Either way. But now in this second alternative, so now in C1.m1, we chose the catch option, which means we do try and catch rather than throws. Yeah, let me finish this and then I'll come to you. Yeah. Okay, so now, question for you. In this particular class over here, am I obliged to handle the NAE? No, that's the idea. As soon as the try and catch has been used at one level, all the further level of callers, they don't have to handle this anymore. Okay? So now this no longer need to handle negative amount exception because it's handled in C1.m1. Okay, that's critical, right? You can just imagine. Of course, again, it's a design decision. It's really hard to say which one is right, which one is wrong. That's why I'm trying to just make it general. But the more important for you, as far as this course is concerned, is to see, first of all, imagine there's got to be some place where a particular exception can be thrown. Let's say C2.m2. Okay. Let me summarize this, and I'll take your question. Okay. So there's got to be somewhere. Where a particular exception is thrown. That's the original place, and then throughout this particular chain of calls, you have to make a decision at each level. Okay? You may simply keep specifying until the client see the exception thrown to the console, but that's a worst scenario. Okay, that's one possibility. Or you can say, at some point, I'm going to use the catch option. Okay, so this is the first catch, first occasion where the catch option is implemented. Right? That's exactly what we did over here. And as soon as this has happened, all the further callers, they don't have to handle this exception anymore. Okay? That's the principle. You got a question? Yes.
For the specify method, do you have in the body of the method, you have to say throw exception,
You don't have to. Okay. Let me see if I got your question correctly. You're basically asking, let's say this. Okay. Again, let me make it clean. Let's say C1.m1 calls C2.m2. Okay. Let's say for C2.m2, let's say somewhere in the implementation, we simply say if something happened, we say throw new. Some negative amount exception, let's say. And then as we said, as part of the signature, part of the header for M2, we would say throws, right? Throws negative amount exception, right? That's the first one. Is your question asking, let's say for C1.m1, that's a caller, right? Let's say we chose a specify option, which means we're going to say void, and then we'll simply do M1. And then if you choose the specify option, you'll say throws negative amount exception. And now, because somewhere you will have C2, let's say objects is new C2. And then you simply say O.M2. Right? That's exactly the caller-callee relation we are expecting. So is your question about, when I already put this line, do I still need try and catch? Is that your question? The answer is no, you don't have to. You choose either catch or specify. You don't choose both. So what you're asking was, can I write rather than just a single this line, right? Because I know that M2 potentially can throw negative amount exception. That's why I'm choosing the throws option over here. You're asking, can I turn this line, so assuming that I already got throws, can I also say try O.M2 over here, and then catch, and then negative amount exception? That's what you're asking, right? For each, oh, you mean, or what should you put over here? I don't quite get your question. Let me finish this first. So, first of all, you don't do this anymore because that'll be redundant, right? Because I already got throws the specify option, I shouldn't do catch option at the same time in the same method. That's number one. And can you say your question again? Yeah. You mean over here? Throws? Okay, first of all, when you put this syntax over here, be careful. This syntax over here goes like this. You would say throws. And there's no new. Right? You only do the new when you actually have that particular error. That's the place you just throw it. Okay, the original place, yes. So over here you say throws, and now what should be followed? What should follow? It will be a list, comma separated list of the exception names. Okay? Example here. Okay. So now let's say I got, let's say void M1. Okay? So now let's say this. Okay, I'll just put it like that. You might say if condition 1 is true, I would say, I would say throw new, let's say E1, exception 1, let's say. Exception 1, some error message over here. I can say if something here, I would say throw new exception 2. Okay, and then after this, I can do some stuff. So now for this particular method setup, potentially I might throw either E1 or E2. So now let's say in this original place, we usually opt for the specify option. How can we declare that? Okay, so we would say throws no new. Okay, and then you'll simply give the name of the exception. So you say E1, comma E2. Okay, any question?
How to do the try and catch at original place?
Oh, that's exactly what I just mentioned. Can you do the try and catch in the original place? You could, but it's not very sensible to do so. Okay, so basically that's, if you refer back to the notes over here, so this is the original place where the pay may throw the oh sorry, let me say over here. This is the way I want to refer you to. Okay, so now let's say we are now in the account class, and then we talk about the withdrawal method over here, right? So this is the place where you throw the new negative amount exception. That's the original place. You're basically asking, can we choose the catch option? The answer is you wouldn't do that, even though syntactically speaking it's legal, but people don't usually do that. The reason being, this is the very original place where this error is occurring. Why does it occur? It occurs because somebody calling this method over here is passing some negative a over here. So who should be responsible for this negative amount? Whoever the caller is. That's why at this level here, it will simply propagate the exception to the caller of this method. That's why.
So when you're creating like classes and methods and other attributes, you usually use like the public and private modifiers. Is that something that?
Oh, okay. You talk about public versus private. I wouldn't emphasize public and private so much because they're more like a modifier to say whether the attributes can be accessible outside this particular package or not. That's nothing to do with the logic of programming your classes. I would say in your lab tests, you can assume that you have only one single package, default package, in which case declaring private versus not declaring private is okay. That's not our concern over here. Yeah, I can talk about maybe public versus private, maybe conceptually, maybe a little bit later in the course. Yeah, but that's not really has anything to do with the logic of programming your application. Okay. Yeah, but don't worry. Yeah, but so in the programming test, next Wednesday, right? Sorry, next Tuesday. Next Tuesday, you have your programming test. Basically, you can simply leave out the public and also the private for your methods. If you really have to put some public or private, I will notify in the instruction. You'll be very clear.
For classes, we need them, right? For initial class, right? We need them.
The initial class? What do you mean the initial class?
Like when you're creating a file, right?
Mm-hmm.
Give it a class, you have to say public class.
No, you don't. You don't have to. Basically, the public simply means any other classes in the same project can get access to that particular class. If you leave out the public, that's fine in some occasions. In the test, we want to make it simple. If you put public, that'll be fine. If you don't put it, that's also fine, right? But anyway.
Does the same go for methods?
Yeah, the same goes for the methods, yes. If there are really some very special occasions, you must put private or public. I will signal that very clearly in the instructions. Yeah, that's not something I will test you about. Yeah. Okay, that's about exceptions, right? Okay, you still got 1 hour if you want to take it, right?
Trace number 7 on the practice.
Yes, number 7. Absolutely. Okay, let's go to the practice over there. Okay, first of all, let me go to the, I'll go to solution directly, that's fine. Number 7, you said? Okay. Okay, number 7, let me see if this might work. Number 7, we want to trace this code over here. Let me see if I can copy and paste. If that works, that'll be great. If no, I'll just write. Okay, never mind. Okay, so now let's have a look at this particular example over here, number 7. Okay, we're assuming that we're assuming that the person class has already been defined, and also each person object has name, has the attribute name, and also we have a constructor initializing the person. Let's say, okay. So let's try to trace it. I'm glad you asked me, actually. Okay. Do number 8 as well? Instead, no problem. Not a problem. Anybody want me to do number 7 as well? I don't mind. Or just number 8? 7, 8, and 9, or what do you mean it's fine? You mean you don't mind, or you'd rather just do it? You mean this? Okay. Okay. Anybody want me to do 7 first of all? Don't be shy. 7. Okay, I'll do it. 7, 8, and 9. All right, not a problem. You know, in the review session, don't be shy because this is your time, right? So any question would be okay. Yeah. Yes, you want to ask some question first?
Just before you start, I have a question about exceptions. What happens if a method throws multiple exceptions, and then you decide to handle the main method with a try and catch?
Mm-hmm.
Do you have to like create specific try and catch
For each one of them?
for each one of them, or can you handle all of them try and catch?
So the question was, let's say, okay, I'll talk about this very quickly, about exception, and then I'll go back to this example, okay? I'll refer you to maybe this particular slide very quickly, okay? That might help. The question was, what if the method you're calling, I'll just go there first, and then we'll talk about it. So if you go to the exception slides, I want to refer you to this one here, okay? Okay, let me make it bigger. Okay, so now basically this fragment of code is doing many things. You can see, okay, I'll try to use the mouse a little bit. You can see number 1, you can see there's a bank object created, and also we are trying to say b.deposit, also b.withdraw. If you refer back to the previous slides, we know that withdraw has the potential of throwing the invalid transaction exception, for example, right? That's I'll just put it in green. On the other hand, in the same fragment of code, we also try to say c.setRadius, where c is a circle. And the setRadius can also throw another kind of exception called negative radius exception, right? So now, if you only consider this block of code, let's say, imagine you don't have to try and catch. Only this block that I'm highlighting, only this block. If you only enter this block of code into Eclipse, again, it's going to complain. How many complaints do you think they will have? 2 complaints. Basically, the principle is for every method call where the method you're calling has the potential of throwing some exception, but you don't have the corresponding catch or specified requirements implemented, they will have a warning, right? In this case, we know that this might throw the exception, so you have to handle it. And this might throw another kind of exception, you have to handle it. Okay? One way to do it is simply I put everything into a single try block. And then you may have more than one catch block associated with it. I'm saying if this particular exception is thrown, negative radius exception is thrown, I handle that one way. If I got another one invalid transaction exception thrown, I'll handle it another way, right? Okay, just a quick explanation. Does that answer your question? Okay. Okay, let's go back to the practice over here. All right, let's do it. Okay, before I do it, I just want to refer you to the example we did. Let me refer you to that very quickly, and then I'll do this one. Because in some way, 7, 8, and 9, they are the simplified version of what we did in the class, right? Let me just tell you where you should go to before if you want to do some last-minute study. If you go to your classes and object slides over here, right? We want to go to the part about aliasing. I'll show you. Aliasing should be somewhere, yeah, over here, good. Okay, so now, remember this example we did together, right? Alan, Mark, and Tom, and an array of size 3, and we traced it completely in the class, okay? So maybe you want to make sure you're comfortable with an example of such complexity. And the practice question you were given is only a simplified version of this. Okay? My point is, if you want to double check your understanding, maybe find some time today, go to that particular part of the lecture, review it. Okay? That's my advice if you feel uncomfortable about it. Question?
Would the question on the exam be of that complexity, or?
You mean exam or the test?
The
the test.
Yeah.
It's possible.
Okay.
How much time do I expect you to solve it? Maybe 15 minutes? 15? Reasonable? Yeah. Oh, yeah. Oh, well, the number of questions doesn't really matter because maybe one question could be, oh, define the concept aliasing. That shouldn't take you more than 2 minutes, right? Right? I would say, don't worry, I'll be reasonable. Basically, I tell you how I designed the test. I can tell you this, okay? Since, well, let me say this, because people might be interested in hearing this, right? Typically, when I make the test or exam, I will go over the slides and also the iPad notes myself. I'll try to see what I cover in the class. Because my principle is I only test you what I teach. So I'll go over that and say, oh, maybe when I talk about this example here, it trigger many discussion in details. So maybe that's something I can test them about. Okay. But an example like this complexity here, I do expect you to know since we did spend time in the class, right? If you really found that maybe up to now you haven't spent as much time or effort in the course as you should have, it's not too late to fix it, right? It's only an early wake-up call to you. Okay. Yes?
Another question I wanted to ask, but it's already there.
You mean for this example specifically?
Not for this example, but in general. For arrays.
Arrays, yeah.
Yeah, so for example, line 6 and lines 8.
Okay.
When you do person and position in brackets, why is persons one dot length without, it's not a method call, it's without
Oh, okay.
parentheses.
Okay, so you're asking this, okay, just about syntax, okay.
Yeah.
Okay, no problem. So, so if you look at this, first of all, persons one, what's the type for persons one? Persons one is simply an array over here, right? For every array variable you declare, you always can use that length. Okay, it just predefined like a variable that's defined on every array objects. You can just say the length, right? So you guys did use primitive array in your 1022, I assume? Okay. Yeah. If you haven't, learn it now. You need that very badly for next week's programming test. Okay. Okay. I'm just curious. No, I'm not going to make the test harder if you haven't done this, right? How many of you have already not, oh, maybe in a positive way. How many of you have started watching the birthday book example that I released? Have already positive. Oh, okay. Good. Good for those of you who actually have started. You haven't started, my friendly advice, you're already behind. Okay, start. Okay. Okay, so that's about the length. Okay. Basically, for every array variable you have, you can call that length. That's pretty much the only thing that's predefined for you. Okay, let's go back to the test question. Let's go over that. There might be something more I can review when we go over them. Let's start with number 7. Okay, number 7 over here. Okay, so now let's see this. If you want to solve a question like this, the best way to do it is by drawing diagrams, right? That's why I keep doing it, in the class. Okay, let's do number 1 and number 2. If you got a piece of paper, why don't you practice with me together, right? Grab a piece of paper. Let's see line number 1 and line number 2, okay? I'll give you about 20 seconds while I'm drawing it. Okay, question number 7, okay? For line 1 and line 2, what's going to be the diagram? Okay, give it a try. And we assume that there's only a single attribute in the person class called name. Only a single one. Okay, I'll give you another 20 seconds. Okay, 1 and 2 should be very easy to draw, very easy. Okay, how many boxes would you draw? 2. How many arrows would you draw? 2. Good, it's a good start.
You said on the guide that it's going to be test
JUnit slides.
You're gonna cover those on the written test.
Yes.
So like in terms of, would we just need to like?
You know what? Let me finish 7, 8, and 9, and then ask me the question again. Otherwise, we'll be distracted. Okay, just remember to ask me again. Okay. Okay, the first 2 lines. Okay, what I would do is, for your convenience, line number 1. Line number 1 is going to have P1, right, pointing to this person objects. Line number 2 is going to create P2 of this object here, right? So now, maybe you're having trouble with line number 3. Okay, that's the array notation. Okay, what I would do is I'll first copy to iPad and then I'll show you. We say that person array persons is P1 and P2. Okay, if you look at that, so that's exactly this line over here. It's a very straightforward notation. First of all, you have to understand what the declaration really means. So let's look at that. So this person over here simply say store address of a person objects. If you only look at the person alone, okay? That's why when you only got account, that means a single account. However, now the complication is higher because you also got this particular square brackets notation, right? So this means it's going to be an array of. If you combine these 2 syntax together, that simply means we declare persons over here to be of type an array of what? Of addresses. Okay? Yeah, so one of you actually posted on the Google Doc asking me, what does it really mean when you have an array attribute? That's exactly what it means, an array of something. Okay? On the other hand, let me say this and then I'll get to your question. On the other hand, the simplest case, if I simply get, maybe that's what you did in 1022. If I say integer brackets over here and then I'll say ns, right? So now, how do you interpret this particular declaration, right? It's going to be an array, first of all, right? And then every element in the array is going to be an integer value, okay? So one way to initialize this, I'll show you exactly how you can write, okay? You can say this is simply assigned to maybe 1, 2, and 3. You simply pass the values over here. So what this would do is, ns over here is going to store, notice one thing. The ns itself is going to store the starting address of the array. I'll write it down first. Okay? Store the starting address of the array. And the array itself stores a collection of integers, right, in this case. What's going to happen is ns, if you refer to it, is going to point to the beginning of an array of size 3. 1, 2, and 3. Okay? And now, how do you refer to them? You can say ns at position 0, ns at position 1, and also ns position 2, right? 0, 1, and 2. That's the basics. So now, if we want to do this particular exercise question, we're just making it slightly more complicated. We're saying that every element in the array over here, rather than being just an integer, is now going to be the address of some person, which means you have to draw some arrow around, right? That's a complication we're adding. But let's do it. Oh, sorry. Okay, so now how do we do this particular line at the top, the blue one? Okay. So what it will do is, as I said in the class, this line here, one way to the way to understand it is basically equivalent to 3 things. Okay, the equivalent to the following 3 lines. We say person array, persons is simply assigned to the starting address of a new array objects, new person. And now, because we know we're going to initialize the array to be exactly P1 and P2, so size 2, right? And then after this, we know that P1 should be at index 0, P2 should be at index 1. So we would say persons at position 0 is assigned to P1, followed by persons at position 1 is assigned to P2. Okay, so these 3 lines is exactly what this single line means, either way, right? Any question up to now? You okay? Yes.
For the integer array,
Yeah.
so it's not a point, it's not an object. So, but you said ns is pointing to that array.
Oh, okay. Basically, thinking this way. So first of all, we know that ns is basically pointing to the start of this array, number 1. And now, when you say ns 0, think about it saying that go to index 0 of this array and tell me what's in there. In this case, it's only value 1 that's there. In the case where you say it's going to store person addresses, and what's in index 0 is a person address. That's why you can go further to look up that position, to look up that address in the memory and do something about it.
I mean, isn't that objects are references? Like
Yeah, object, yeah.
addresses, But integers are not like,
No, integer are like a primitive type still, so they are not references.
they're like an place that, for example, put tree in or something.
Yeah, exactly. So when you say ns at position 0, you're just referring to that particular value 1 over here, right? That's what you're doing. However, how about this? Delay your, we can continue with this, but delay this a little bit. Once I show you how exactly this can be drawn in the reference case, you will see the comparison. How about that? Okay? Questions? Yeah.
So, again, well, you're saying like the first line, the person stores the address of the person object.
No, the persons, no.
I think that's the type.
Yeah. Okay, persons over here, okay, again, persons over here. This one, let me use a different color. The persons over here stores the starting address of an array. Because persons, basically, later on, is simply just going to point to an array, like this. Okay? Now, what about the array that's being pointed to? The array itself, every element is simply just going to be a person address. That's the difference. The person's variable over here is just about pointing to some array. But for the array itself, it stores many person addresses. So the persons, okay, I see where your confusion might come from. Okay, I'll write it here. Persons, okay, it does not store person addresses. The person itself, it does not store. It points to an array where the array stores the addresses. Okay, that's a critical difference. Okay, so good. So now let's try to understand how to draw this line over here, right? Any question about interpreting this line here? Interpreting this line here is equivalent to these 3 lines over here. Any question about it? That's a critical part. Any questions? Okay, assuming that you're okay. So now how do we do that? So the way to do that is persons is going to point to the starting address of some array. In this case, array should be of size 1 and 2. 2 things, right? Okay, so that should be index 0, index 1. So now, how should we assign P1 and P2 into each slot of the array, right? So that's why this alternative definition over here could be useful. Okay, let's do the first one. We say that persons at position 0 is assigned to P1. So that means we are copying whatever address that is stored in P1 into index 0 of persons, right? So now you can think about P1 is storing the address of this person objects, right? Now we are copying the address into persons at position 0. We're copying that. For example, the object over here might have 06111, for example, right? In that case, I'm going to copy 06111 address. However, the way to draw it at a higher level, that's not how you draw it. The way to draw it would be, now in this case, when I want to execute this line here, so persons at position 0 is now pointing to wherever P1 is pointing to. Questions? We okay? Well, some of you don't look very comfortable with this. Okay. Any part that you got confused? I can tell you this is important. Right? Yes.
Maybe what you meant by does not store the person's address.
You mean the person's over there? Okay. Sure, of course. When I declare this, I say person, array, persons is something. Okay? So now, the persons over here, the way to refer to it is persons is pointing to an array, first of all. Agree? Okay. So now the person itself only stores the starting address of the array. Okay, which means the person, you might simply store, for example, 06001. Okay, and 06001 is only the starting points of the array. Okay, number one. Okay. By the way, when I talk about starting address, this is something you will learn later in 2031. I don't want to bother you too much about this, but when you program in C for 2031, they will talk about the insight into the indexing notation for array, but I wouldn't bother you with that. I'll just give you a little bit intuition. So now, persons stores only the starting address of this particular array, only the starting one. The persons variable, it does not store any person objects, does not store any person objects address. It is this array that is storing. Okay, so now at the runtime, what you will see is, let's say we got this many elements, right? So any one of them, for example, 1. So this one here is persons array, which is starting point of the array. And now I say go to index 1. Okay, so now that's the second one. So now what this one means is, so persons 1, a slot, this one stores a person object's address. Okay. Again, persons variable here stores only a single value, which is the starting point of the array. On the other hand, every element in the array stores only also a single value. Each one of them stores the person's address. Collectively, you got many person's objects being stored collectively. Right? Yes.
So with person storing a certain address of the array,
Yeah.
does it have the address of person 0? Or is it kind of like
Okay, good question. A little bit more detail here. The starting address of the array and the address of the first element in the array, they are the same. Okay? And now, I don't want to go any further. That will take too much time, right? That's not your concern for now. Okay? Okay, so one more thing, I'll just make a note, exactly what I just meant to you. So, starting address of the array has the same value as persons at position 0, right? The starting point and also what's stored in the first one, they are the same. Okay, yeah. Okay, having understood this, let's go back to where we were over here. Okay, let's now complete the diagram. Okay, to the next step. How do we do this? Okay, what I just did, I say person 0 over here, person 0 is copying P1. So that means person 0 is now going to store the same address that is stored in P1. So conceptually, this is now going to point to the same objects, the same as what P1 is pointing to. Are we comfortable with this? That's a very critical step. Okay, let's do another one. And the next one would be, let's say, next one. So now what about the next line? persons 1 is assigned to P2. That means we're going to store something in persons 1. Over here, what do we store? P2. P2 is pointing to, conceptually, this object here. So now it is now going to point to this. Are we okay? So now, a little bit of checks quickly. I'll do number 7 a little bit more thoroughly, but 8 and 9 can be done a little bit quickly because they're essentially similar. So now, after this initial line, okay, I want you to think about the following thing. After this, okay, so if I ask you, for example, to try persons 0 equals P2. Persons 1 equals P1. Well, as you guys know very well, equals means we're comparing addresses, right? And we'll do actually more about comparison today in the class, but in a slightly more complicated context, but you don't have to worry. But for now, as far as the lab test is concerned, whenever I try to use an equal, and that means I'm comparing if the address that is stored in the first slot of the array, is that address the same as the one stored in P2? Okay? Or diagrammatically, is this particular slot pointing to the same objects as does P2? True or false? Okay, I heard false. That's good. Okay. Why? Because person 0 is pointing to this particular object over here, whereas P2 is pointing to this object over here. They're pointing to different objects, right? Okay, that's why it's false. Very important for you to know. Okay? Questions? Yeah. Okay, you're basically asking, modifying this example a little bit. Can you hold that question? Let me finish this particular example quickly for completeness, and then we'll do your changes. I think it'll be better, okay? Yeah, I'll get back to you. Okay, so let's finish that, okay? So this is after, okay, after line number 3, okay? So now let's do line number 4. P1 is assigned to P2, okay? That means we are trying to do some arrow changing or reference reassignment. When we say P1 is assigned to P2, okay? Let's try that. When I say P1 is assigned to P2, am I changing where P1 is pointing to, or am I changing P2 is pointing to? P1, right? Okay, so P1, rather than pointing to over here, P1 is now going to point to here. Okay, good. Sorry, the diagram is getting a little bit messy. I'm sure you can draw a much better one than mine. Okay, so now after this, one more. Person 0 is assigned to P2. Okay, person 0 is assigned to P2. Persons 0 is assigned to P2. Okay, so now you should follow the same logic. We know that we are changing where person 0 is pointing to, right? Persons at position 0, rather than pointing to over here, it's now going to point to P2. So now it's now going to point to P2. Okay, a very quick question for you. It's also very possible for tomorrow, okay? I might just give you a fragment of code rather than asking you what's going to be the printout. That could be one way to ask you. Now, I might simply say now, at the moment, list all the names which stores the address of the person with the name JUnit. How many of them? How many names do we have? I heard 4. That's a good number, right? If you look up your diagram, you will see that 1, 2, 3, 4. 4 arrows, first of all, right? Okay. So now you will see number 1, you got to figure out how many. 1, 2, 3, and 4. How do we list the names? Okay, let's try. I'll do the first one. That's the easiest one, and then I'll let you contribute. P2. Agree? Next one.
Persons one. Person at position one.
Persons at position 1. I agree. Next one.
Person at position zero.
Person, oh yeah, exactly, that's this arrow here, right? One more?
P1.
P1, right? So these are the 4 names for this particular object, right? Aliasing. So that means if I want to modify the name for this object, it does not matter which name I'm using. If I say P2, that set name, it will be effectively the same as saying persons 1 dot set name. They will just be the same. So that's aliasing. Okay, good. Okay, very good. And let's go a little bit further. So now let's say, okay, this one should be very straightforward. System and other print line, persons 0 equals P1. I'll write it out and then we'll answer that together. Okay? Persons 0 equals P1. True or false? Okay, let's double check. All you got to do is, I'll show you what you should do. First of all, okay, we are doing this, right? Okay, persons at position 0 is currently pointing to this particular object over here. And then we want to compare with P1. P1 has been reassigned already. So P1 over here is also pointing to this particular object. So they are the same, right? So that'll be true. Once you have drawn the diagrams correctly, any question I ask you about should be very straightforward. Just look at the diagram, right? Yes?
Before you change the person 0 to P2,
Okay.
is that address still pointing to where P1 is pointing?
Yes, you're basically asking over here, well, if you say before, right? That'll be a little bit harder to draw. Okay, anyway. The question was, one of the assignment we're trying to do is to say person 0 is assigned to P2, right? Okay, you know what? For complexity, for completeness. We can do number 7 in 100% detail, but I think for 8 and 9, if we time permit it, I'll go a little bit further. Otherwise, we'll leave that to you. Okay, let me be precise. I think I can see where confusion comes from. Let me make it clean, okay? Okay, let me do very quickly. Okay, we got P1. Person over here, we got Hyun over here, and also we got P2. And also we have person, the name would be JUnit. Okay, and then after this particular line, okay, we need to trace them through, okay, persons, okay? And the persons is just going to be an array. The starting point of the array, index 0, index 1, so like that, okay? You're basically asking about, oh, let me do P1 equals assigned to P2 first, right? Let's do that first. P1 is assigned to P2. P1 is assigned to P2. That means changing P1 to now point to P2, okay? So now you're basically wondering about this line here. Person 0 is assigned to P2. Persons 0 is assigned to P2. Okay, that's what you're wondering about. Okay, think about this. This is an assignment, agree? This is an assignment. And whenever it is a single assignment, which means you only modify this particular targets. So this is the only place modified. That means whatever that used to be stored in persons at position 0, only modify that part. Okay? So now what will happen is, let me do that and then you can ask questions again. So now what I would do is, persons at position 0 currently is storing the address of this person object. Agree? Okay? And we're saying that rather than storing that,
Is storing P1 or the address of P1?
no, P2.
Before that.
Before that. Before this cross is happening, person 0, yeah, only the address, of course. Yeah, remember when we talk about reference type, again, you never store the contents of the objects. You only store the address in direction.
So
You just change the arrows.
So the array still holds the old value for P1 initially? No.
Nope. So you mean the person's object or the array?
The array.
Okay, let's look at this. When I say persons at position 0, it's referring to this slot, first of all, agree? Okay, so now we're saying that changed whatever that's stored in this particular slot. Rather than storing this, it's going to store whatever that's stored in P2. P2 stores the address of this object, right? So that means now persons at position 0, rather than pointing to here, is now going to point to this object here. So we are changing not the objects, but the slot of this array over here to say point there instead. Okay, make sense? Yes.
So if you wanted to call it after P1, then it should be your local pointer again?
Okay. Let's say, okay, after all these, if you simply say P1, for example, dot get name, what it will do is it will simply go for P1. P1 is over here, right? So P1 dot, you're simply going to follow the arrow is pointing to this particular object. It's not null pointer exception because it does point to something.
If you want to access nothing is pointing at that.
You mean this object here? The other one. So yeah. So basically, in this case, I tell you what. In this case, this object becomes anonymous, right? Because there's no name for that object. You just cannot keep track of that, right? Okay. Yeah. So basically, for this particular object here, yeah, that's something just for your knowledge. So for this particular object, after everything has been done, no variable is pointing to it. So that means it's useless. So you'll be garbage collected a little bit later.
Would it, for example, would it trigger a null pointer exception if we said persons at position 0 is equal to null, and then P1 is P1 assigned to persons at position 0, and then P1 dot get name, for example, would trigger a null pointer exception or no?
Let's see. Okay, let's go a little bit further. Okay, let's say this is what we have done so far. Okay, let's hypothetically, let's do some line that you're suggesting. You're suggesting, for example, if I say persons at position 0 is simply assigned to null. Okay, and then okay, that's a good question. Let's talk about this as well. Okay, guys, have a look at the blue line I'm trying to write at the top, the bottom left corner. Let's say after all these, I'm trying to do something new. I say persons at position 0 is assigned to null. Okay, and then I'll try to do the following. If I say, for example, okay, guys, please. Okay, number one, I can say P2 dot get name. Number two, I can say persons 0 dot get name. Okay, let's consider this. So the diagram is exactly what's drawn over here. Okay. So now, before the blue line over here, let's just see what's there. Before the blue line, before this line was executed, notice that person 0 is pointing to this particular object. It's not null. And also for P2 is simply pointing to the same object, right? Before this line. Okay. So now let's say we execute this line. We simply assign person 0 to be null. Let's say we do that. Okay. Without updating the diagram just yet, is 1 going to give me a null pointer exception?
No.
No? Yes? No? How about 2? Okay, so I believe there might be the confusion of some of you. Okay, let's look at that. Again, whenever you're trying to do assignments, you're only changing a single place. Okay, so now when we do that, number 1, so now persons at position 0 over here, rather than pointing to over here, is now going to point to null. And at the same time, P2, which used to point to the same object here, doesn't get changed. does not, negative. Some of you got confused, saying, oh, since before the change, let me do it again, because before the change, these two point to the same objects. So that's why when you redirect one thing, you should redirect the other one as well. That's wrong. No, that's not the way to go. Okay? Whenever you try to reassign the variables, you only change that particular variable you're talking about on the left-hand side of the assignments. Okay? So that is why over here, when I say %0, I only change this one only. I don't change P2. I don't. Okay? So now it's assigned to null. Rather than pointing to here, it's now going to point to null. So now for number 1, P2.getName. P2 remains to point to this particular objects. That'll give you JUnit, right? On the other hand, when you have %0.getName, right? So now %0 has been redirected to just null. You're basically saying there'll be null over here, and then dot again is going to look up the address for null, go to that memory location and call getName. Null is a meaningless address, so there'll be null pointer exception. Okay, notice that. Okay, I think it's a nice question here. So now I should show a little bit extension to the practice question. Okay. Any question about this before I take your suggestion? Just in a moment. Yeah, if you still remember it, right? Yeah. Any question about this? Number 7, number 8, number 9. I can do it very quickly. Okay, a few minutes will be enough. Okay, can you repeat your question again, please?
Sure. It's kind of a question about arrays, how they
How you remove an array?
modify them.
How to modify them? Okay, I'll just maybe talk about it a bit in a general way. That will help your programming test. How about that? Okay, so how do you modify an array? Very easy idea. So let's say if you declare, let's say, person array, right? Okay, so now you can either say brackets notation over here, comma separated expressions, or you can say, how do you, also let's say persons 1 and also persons 2, which would be maybe new the array, and then with certain size over here, let's say 3, for example, right? Okay, to initialize the array, either use one way or the other. But I would say typically, this way is more general. Okay? So now how do you modify the array? Typically, the only way you want to modify the array is to go to a particular position and modify it, right? Let's say, for example, let's say persons 1 is pointing to the starting point of some array. Let's say somewhere we got index I, for example, right? Index I. And index I is now, of course, potentially maybe pointing to null, potentially. But let's say it's now pointing to some person objects, right? Okay, with some name over here. So now, typically the change you would like to make is to say maybe persons 1, and now go to index I. Okay, index I over here. And now I want to say rather than pointing to this particular object here, maybe I want to point to null, or I want to point to another object, right? Let me say just null. Okay, I'll just say null. What it is doing is the size of the array remains unchanged, right? However long it is, it remains to be that long. However, it is mainly the persons 1 at position I that we're changing to just pointing to null or pointing to another object. Is this somehow related to your original question?
Mine's actually, I'm just curious what's on, so I can ask you after.
No problem. Yeah, let me, guys, for those of you who have not started your birthday book exercise, let me tell you why I really want you to start earlier, otherwise it'll be too late. Because for the programming test, you will be required to actually somehow shrink the size of the array. Okay? Conceptually, how would you do it? Okay, I'll give you a little bit tease of this. That's why you really want to start. You don't want to delay this, right? Let's say this. And then I will just finish 8 and 9, and then we're done. Okay, how about that? Okay, so now let's say this. If I have an array A, let's say I simply got index 0, index 1, all the way to index I, for example. And then after this, I got all the way until the end. Okay, of course, this is I plus 1, I plus 2, right? So now a question for you. Let's say we only got only up to 99, so we got 100 elements in the array. How do I delete elements at index I, so that the array will now be of size 99 rather than 100. Okay, let me just draw that quickly, and then I'll take your input. What I want to have is, after the updates, it's now going to be basically 0, 1, and all the way to 98 instead. Okay, basically I want to delete this guy here. Yes?
Doing a for loop that says if you're not currently at array A I index section,
Yeah.
add it to the new array B, and then after that you can say array A B2.
Something like that. Yes, something like that. Yeah. So if, okay, yeah, you want to say something? Yes.
Just like quick clarification. So if you're decreasing the size of an array, you have to make a new array.
Exactly. So let me just repeat that. So now the tricky thing, that's why I want you to start the tutorial earlier if you haven't known how to do it, right? Some of you might know, but I don't assume that. That's why the tutorial video is going to help you. So the idea is to go from this to this, right? You got to first of all create a new strictly smaller array of size -1, right? Smaller array. And then number 2, you have to use a loop to copy everything, everything except A at position I. Copy everything except for this into the new array. This is something you have to know how to do in a programming test. Okay, that's why if you haven't seen this in the video, you better see it. Okay, because you still got time to ask me questions. Okay. All right. Okay, let me just go back to 8 and 9. Okay. Do we have agreement? I'm going to finish 8 and 9 and no further questions. We got any other question I can answer? Okay, how about do 8 and 9 quickly? Okay. Okay, number 8, it would be very similar. Okay. How about just do number 8? So we only got about 5 minutes. Okay. Also, you want to get your lunch before our class, right? By the way, we still got class at 1 p.m. Right? I'll be very upset if you don't come, right? Yeah. But it turned out to be more people than I thought today, which is nice. Okay, how about we just do number 8? Okay. Okay, so let's do a final practice on this. Okay. So now give me 1 minute. What I will do is I'll draw everything up to line number 3. Okay, you may want to do the same. Okay, everything up to and including line number 3. So that's question 8. And P2. Okay, I'm almost done. Yeah, just see how much you can do. Persons. Okay, let's see. Agree that should be the one? Okay, so now let's do it quickly. So line number 4, P1 is assigned to persons 1. Okay, P1 is assigned to persons, oh, sorry. Oh, I don't want to do it wrong. Okay, persons 1. Okay, are we modifying P1 or persons 1? P1, right? Okay, be careful. It makes a huge difference. If I say persons 1 is assigned to P1, I might give you either version in a test. You want to know which one means what, right? Okay, but anyway, this is not what we are worried about, this. So now P1 is assigned to persons 1. P1, rather than pointing to here, is now going to point to wherever persons 1 is pointing to. So now it's going to point to here. Good. And then next one. And then person 0 is assigned to P2, right? Persons 0 is assigned to P2. Okay? So now we are modifying person 0, right? It's now going to point to wherever P2 is pointing to, right? So now person 0, rather than, right, person 0 is here. Rather than pointing to here, it's now going to point to this guy here. Agree? Okay. So now after this, let's do, okay, now we got aliasing, right? So now basically you can see that, look at this, okay, P2.setName. Okay, I will point out something. So P2.setName. Okay, and then it will just be GA over here. Okay, I want to draw attention to this, okay? First of all, P2 is the context objects, right? Okay, again, you should know the word context object very well, okay? Context objects, okay, P2. And then we can see P2 is basically over here. Currently, it is pointing to this object over here. But now, because of aliasing, how many other pointers are pointing to the same object? How many? 3 more, right? You can see there is one over here, there is one over here, there's another one over here, right? So now, we want to call P2.setName. But my point is, it doesn't really matter which name you're using. If you use either one of them, it's going to modify the same objects anyway because of aliasing. Okay? So now, let's see this. If I try to execute P2.setName, follow P2, you get this object over here, set the name to be GA over here. And now, let's see what the question is asking. So now, system out the print line P1.name. What's P1.name? Yeah, exactly, because P1 is simply pointing to just the same objects, right? So that will give you GA. Okay, I believe number 9 will give you similar, just do a similar tracing. Any questions? Okay, let me say one more thing before I let you go. You want to have lunch, okay? For tomorrow, you want to review the following concept, right, specifically, okay? Aliasing, for sure. How to trace array with aliasing. And also, you want to review static versus non-static. Especially the common errors I show in the slides. You want to refer to them as well, right? And you want to review exceptions. We spend a lot of time. Exception is also important, okay? Especially specify and catch requirements, and which one should you choose? Number 5, JUnits. For JUnits, let me make it clear. You do not have to write any JUnit assertions in the test. You don't have to type it. Expect to read JUnit assertions. Specifically, I want to refer you to it. Okay, I'll show you. Okay, quickly, just bear with me. When you read study the slides, I really care about how you think about the problems. So if you go to the JUnits, I tell you what you should really look at. Form a study group, right? And then, for example, go to the JUnits. Give you one example. Okay, assertions, that's something we talk about. Okay, you should know them. Okay, for example, let's say this guy here. Okay, we got actually maybe 2 or 3 more examples in the class, in the slides. For example, if you look at this example here, pay attention to the following. Notice that we are having assertions at line number 7 and line number 11. Line number 7, we're simply making sure the value that we are getting is simply 1, right? That's line number 7. In line number 11, we simply say if we can ever reach this particular catch block, we're going to fail the test. I want you to understand what the logic is over here. Why, when we reach line number 11, should we actually fail this particular test? Okay, short answer, but I do expect a longer explanation. Short answer is we're only trying to, at line number 6, try and increment from 0 to 1. In this case, we do not expect any exception to be thrown. That is why if anything that's thrown from line number 6, you will be disrupted to line number 11. In that case, that should be an error, a failure. On the other hand, you notice that in this case, fail is put under catch, right? If you compare with another one, you can see the fail right now is in line number 7. We can't swap the order. It's not typo. There's a logical reason behind. It is because now what we're expecting to happen is exception should be thrown from line number 6. Okay, that's something we cover in detail in the class. Okay, things like that. I might give you a similar example or maybe something different, but it's going to be this kind of logic. You want to distinguish between the two different kinds of floats where exception may or may not occur and see which one should be appropriate for the problem you're given. Okay, take a break and then I'll see you in the normal classroom.